Okay, so here's the last little bit, and this is the problem that Patrick Connor was posting about. This is a problem from a New York State math test, and I'm not sure if it was for high schools or what. But the question was the 13, 14, 15 triangle, and what is this angle here? And the choices were: is it about 53? Is it about 59 degrees? Is it about 67 degrees? Or is it about 127 degrees? Okay.
Yeah.
So he pointed out that there's a way to solve this without actually having to know something called the law of cosine, which is what this was testing. And we haven't got to that yet. So he pointed out, and I've made a 3D print model of the 13, 14, 15 triangle. There it is. He pointed out that you could draw an equilateral triangle here. So a 13, 13, 13 triangle, and have a 13, 14, approximately 2 there. And so I've 3D printed that. So here's our 13, 14, 15 triangle, and here's our 13, 13, 13 right triangle. Equilateral triangle. And then here's the leftover bit. Do you see how close those two triangles look to each other? In fact, you want to put them on top of each other?
So this would fit in like this.
That fits in like that.
And this fits in like that.
Like that. Now, is it an exact fit?
Not quite.
Not quite. Not
Just
quite.
a little bit.
But this is an amazing bit geometry observation here. And that helps us see what this angle is, because we know this angle is 60. This angle, since it's not an exact fit, this angle is only about 60, but really close to 60, right? Because these two things are almost exactly the same, right?
Yeah.
And this angle here is 60, right? So that means this angle must be 120, right?
Yeah, this angle facing it.
This angle of this triangle is some small number, right?
Really small.
Okay.
So.
But let's say it was. What do you think this small angle would be? What would you guess?
I would guess about 10 degrees, maybe.
Okay. So let's say this was 10 as our first guess. What would it make that angle there?
Then we would have it be around this should be about 50.
This would be about 50. Okay. From that observation only, which choices are you able to rule out right away from choice A, B, C, and D?
C and D, probably.
How come?
Well, this is more than twice
All right.
that. And 67 would only work if this angle was -7.
Right. So because this is 120, this angle has to be less than 60, right?
Yeah.
Yeah, and even though it's not quite exactly right when that right triangle comes over. So we get the sense that this has to be less than 60.
It means this is either like a 7-degree or a 3-degree angle. Because we have a 53 and a 59.
Okay, so what would it be if to make this 53? What would this angle have to be?
It would have to be a 7-degree angle.
Okay, and to make this angle 59, what would it have to be?
A 1-degree
A
angle.
1. So what do you think? Is this a 7-degree angle or a 1-degree angle?
I think I would go with 7.
You'd go with 7? Yeah, it looks 1 degree is very, very small.
You almost really can't see it.
Yeah, and so this is actually going up some distance as it goes out, rather than a 1-degree angle, which is going to be. It'd be interesting to try to print a triangle with a 1-degree angle on our 3D printer.
Yeah.
So anyway, so this was neat. This is incredible, interesting geometry here. That these two triangles are almost exactly the same. So there's actually, so he discovered, or I don't know if he discovered, but he pointed out that this triangle actually has a second really interesting property, that there's almost an equilateral triangle inside of it. That's pretty cool, right?
Yeah.
All right. Good job this morning. That was a fun project.